Okay, hello and welcome to another ComfyUI tutorial. Today we're going to be covering what I would call mastering the noise, and that is learning to control empty latents, learning to control samplers through input images, and learning the ins and outs of how the sampling process is affected by what comes into it. And through that I'm going to show you how to use noise to kind of add more detail, change kind of the way that your images come out, and to really add an extra level of control onto actually making stuff you want to make, and might be having trouble actually prompting because sometimes you prompt stuff and you just can't get it what comes in your head is not coming out on the image generation, and we can change that. We can increase the likelihood of it doing what you want by actually doing this kind of stuff. And in the process, I'm going to show you how to make a gradient noise module, following along from my modular tutorials. I'm going to show you kind of how generating things using this can kind of affect your images. And we're going to be using a modular workflow in the process. So kind of seeing how these things work in kind of action, as it were. So first off, I'll show you how this workflow works. I would normally show you how to build it, and I'm going to show you more on the actual noise module, the building process. But generally, you know, my videos work out nearly 40 minutes long sometimes, so can't really show you me rebuild the whole thing every time. Okay, we've got our prompts here as text boxes, and we bring them into a loader module, and the loader module just contains a checkpoint, which is an SDXL refined model. So we don't need the refiner, which many of you might be confused about. We don't really need the refiner. If you've got a refined model, it's already done for you. We also have not got SDXL clip text encodes on this, because generally they help make better images, but they're not really needed for just doing quick stuff, which is what this is. We are using a ComfyRoll aspect ratio node in order to provide us with resolution, providing us with an empty latent as well, and providing us with SDXL pre-made resolution, so that we are not creating bad images and we're not having weird artifacts going on. It's also got some other cool settings as well. Okay, and so that's also feeding out into our bus through these particular nodes here, the width and height. Now for the bus, first time I'm actually using one of the bus nodes from WAS instead of just doing a whole bunch of noodles. So instead of rainbows, we're now using these bus nodes. Now, first of all, let's have a look at the main module in question we're going to be using to do stuff and show you how to do stuff. This is the gradient noise module that I'm kind of going to show you how to build. We're going to have color gradient from ComfyRoll in here. We're going to have Vextra nodes generate noise, and WAS suits Perlin noise. Now we could have all kinds of stuff. You can have solid color in here. You could have WAS suits gradient. You could have just about anything which outputs images can be used inside this, because all it is image sources, like generated images or even load images, and they're all in here, and you blend them together. And the output is a mix of a whole bunch of different sources, and it just sends out an image which we then upscale to the size of the rest of the workflow, and then send out as a latent, so that we can replace the latent image. This can also be used in a separate way. We can bring information in and blend stuff to it and then send it out. So this could actually work post-process, or in the middle of things, or before we've actually done anything as the latent source as well. So it's kind of a multi-use kind of thing. We run it. Let's click go. And what it'll do is it'll send out whatever's coming out in this preview over here in the bottom right. Sends it out through here, sends it to all the different modules that we have connected to it. As you can see over here, it's generating a full image using the prompt that we have at the start. There's nothing particularly spectacular about this image or anything like that. You'll notice that I'm sending it colors. It's not really using those colors. At one denoise, it's not pink, not green on one side or the other. And you'll see that these ones will in fact be using the colors. And the only difference is the denoise value is different. And that's because when you're using an image instead of the empty latent that comes in through these things, generally at one, it's only really using the intensity. It's using the black and white or the light and dark information. And further down, as you go down the denoising kind of steps, you use more and more color from the original and more details. So if you go really far down, it starts to look more and more like the original image. Drag that over. You can see it's turned into clouds at 50. And down here it would be mostly just clouds probably, because it's still using a fair bit of denoising at 0.3. So if it ever generates. Another interesting thing is if you're using different kinds of gradients, like if you have color on different, see how it's oriented horizontally, gradient. We're getting some different kind of images. We're getting stuff that's cliff faces and top-down views of things. Okay, so it is actually doing it in an object. Okay. A terrible photo of a ship flying. Okay, so as you can see, they don't really resemble this top one, even though they're pretty close in denoising levels. Now, let's have a look at this. So in order to build this actual module, it's very simple. Let's just remove all of the guts of it. Not that. And these. No, it's gone anyway, whatever. So as with any module for a modular setup, in on the left, out on the right, that's all it is. So all information coming in comes in on the left. Making sure we bring in, the V, the width and the height, because we're going to need them to upscale it. Let's add the upscaler back in, so that's image scale. Someone pointed out to me that it's image scale. Thank you very much. Whenever you, thank you. I was having trouble finding it. Like the name is not upscale in the thing, so you can never find it when I typed upscale. Width and height. That's now plugged in, and when we output to this, we want to make sure it goes through the upscaler. And the reason we do this is we're using the width and height from the original loader, and that allows us to always output at the right resolution that we want to be outputting to the rest of the workflow. Depending on how complex your system is, you might have to mess with this to use maybe a get image size node or something like that. There's quite a few of those around. They're not too hard to find. All right, so let's get back to the guts of the module. You're gonna need a gradient. You don't really need a gradient, but for this example, we'll make one. Make the simplest gradient that we can. Comfy roll custom color gradient, width and height, obviously. We have start color and end color. If these are set to custom, it will use the hex values from the bottom. Hex values can be found on the web. There's websites that will have color numbers for these. You just have to look up hex color. You can also plug in some nodes that will randomize these, which are pretty cool. Now, those must be on custom to use those. If they're on custom, it's going to come out black by default, so it will just give you a black image. I'm going to change these to white and black now. And gradient distance is the how far the blur is, between the two. As you lower it, you'll get less and less blur between the 2 points until you get to nothing. And we're going to make it nothing and preview. The linear transition is where vertically or horizontally the transition point is within the gradient. As you can see, it's at 50, so it's in the middle. If it was at 70, to be down here. If it was at 30, it'd be up further up. And now that we have those two images, we're just going to run this as the simplest form of gradient module we possibly could, where it's just the gradient just plugged straight into that. And we'll run it, and you get to see what this actually does to 1.0. So we're running this as the actual latent. Instead of the empty one, we're running this as that's what we're sending it. Just like an image-to-image process. If you use an image loader or something like that. And you can see it's having a pretty big effect on this, whereas before we had the color, and you could see it wasn't barely using any color at all. And that's because, obviously, when you're at the 1.0 denoising, it uses light and dark more than it uses color information. It can be used to make some really cool images, though. So as long as you know that it can do that, you've got more control over it. You can tell it to do these things. If I add, I'm going to add a different node to illustrate the point. Gradient. Let's add a radial gradient. We'll do the same thing we did before. Black, and then we'll add gradient distance. Done. Oh wait, it has to be like 0.5 for this. Cancel the job, and then okay, so now we've got this. So we'll increase this to 15. For this one, it changes the size of it rather than the blurring for whatever reason. Okay, now if we go and we just plug this into it. So all black, white, dot in the middle. And you get to see it do something else. I don't even know what it'll do because I haven't tested it. It's probably be in a tunnel or something. Or it could be a planet in space. Really up to the denoising process what it wants to do. And because it's really high on the denoise, if it thinks it can do something else, it will actually add details to it. But so clearly it not exactly following this hard line approach here, and that's probably because there's a little bit of smoothing kind of gradient going on. Let's see what it does if I want to show you a trick here. If you're ever working with grayscale stuff like Perlin noises or this kind of radial thing, if you mess with the levels, you can actually make it a straight black and straight white image as well. You just have to raise the values. Well, get them close to each other anyway. Cancel first job. Whoops. You need to be somewhere in between those. It's probably RGB. That's what it'll be. Sometimes you get problems with custom nodes trying to use alpha channels when they're not allowed to use alpha channels. And it breaks things, throws errors. Now, whether or not it will do that in this case. Are you going to render the whole workflow before I get to it? I'll force it. Sometimes the order of things gets messed up, so I'm just going to jam this in here to force it to actually do these nodes. Do the nodes I have selected, please. Thank you. Alright, so as you can see, I've now removed that blur from around this by changing the level. So there's another little trick. And images to RGB fixed the bug that was happening there because of that. So if you ever get like a weird error that's just being thrown when you're trying to use blends or mix images together, images to RGB can often fix that, and it's because one of these other ones has added a channel to your image, which it shouldn't. And that's really node creators' fault doing that. They really need to be careful with what they're outputting, and sometimes they include alpha channels without giving you an option to turn it off. Cancel that and we'll run it with just the little dot, which is probably going to change the, it does do those, but it hasn't really done a whole lot to this, and that's because it really abhors just a full black and white image. It's got enough power with 1.0 to actually change the simple dot into an actual image. But the bright point is still situated around this central region. Now if we look at the other ones, you can see it's generating kind of like astronomy pictures because of that central dot. But this is just at 70 and probably 80 is going to be the same. Just a little bit extra, and it's already throwing completely different images than you got up here at 1. And the reason for that is because when you generate images, let's bring this up, it really, this is kind of what it does a couple of steps in from the start of generating, and you'll see it's really blurred it. It's really added a whole bunch of noisiness and odd colors to the image. And that's kind of how we generate images. It blurs everything completely. At 1.0, it'll just completely mess up your image. And this is 2 out of 20. I'm terrible at maths, so I don't know what the denoising level of that is. But if we set this to 0, grab it at, yeah, about there. It basically doesn't really use the original this image at all when we run stuff. So cancel, run stuff, and you'll see that it's like a completely different image. It's not even using this dot at all in the image, and that's how we actually get this denoising stuff to actually make things that aren't being sent to it. Which is why when you send image to image with a 1.0, it won't really make you what you think you're making. But give it a little bit, give it 1 or 2 frames of using your actual image, and it will drastically change the output of the sampler as well. So let's make this more complicated now. Let's remove this, else we do not need it. Let's change this to being, yeah, we'll make it blurry in the middle. We'll give you the blurry one. We run this, we cancel the job again. We're getting a simple gradient in the middle. And as you can see, at the very start, there's this solid chunk of black at the bottom of the image here. And that's because when you have big solid chunks of color, solid chunks of either color or light and dark, usually light and dark at denoise of 1 or whatever, it will actually use those, like those big chunks of color, in order to make those bits stay, but it very quickly changes the colors, the pixel RGB values. So as you can see, it just creates this weird black cutoff down the bottom of the image, and the rest of it's kind of normal. Now if we reduce the gradient distance, cancel and run it, so now we've got more white up the top, more black down the bottom, and they're big chunks of it. And we look down here, we see that now we have this kind of interface going on. It's not as drastic as the original, just the binary kind of image. You can see how we are actually influencing, even at 1, we're influencing stuff. So, how can we improve images using this? We can't really do a lot to 1.0. There's not much we can do. We can't really send it anything more than a white or dark image to influence something denoising at 1. But anything below that can be pretty heavily influenced by intense color, intense bright, and intense dark sections of an image. So if we are using that process on these lower ones, you can see it is actually making it like this. Now if you tried to prompt that, it would be very difficult to prompt this kind of layout, because Stable Diffusion abhors big areas of nothingness. It wants to add details. And whereas if you're using those kind of gradients, you can force it to actually do that. And in this, you can see that it's at 0.7 denoise. The big chunks of white and dark, it can't use those, but it can use the gray bit in between in order to make features as well. And it's added some buildings and stuff like that. Now at 80, it's got more power over what it can do. It can change the image even more. You can add more RGB change, and so it's changed it even more, and it's more of this has changed, more deeper colors, more detail. The higher it goes up to closer to 1, the more it changes and is able to change even the dark sections of the image. As you can see at 60 denoise, it's unable to change it really, because there's not enough room for it to change those RGB values to anything that it can actually make images out of. Now, if we change what we send it, we can actually allow more for this. We can give it some more use. So let's grab Perlin. Perlin noise just makes clouds, light and dark clouds. Very simple node. You don't really need to mess with this stuff. Scale changes how close to the camera the clouds are, really. Octaves changes the crumpliness of it from memory. Persistence, not exactly sure what it does. Something. I've never really bothered to investigate what the values really do. I just use it as the default normally. Alright, now we have two things here, but we want to use both. So what we can do is we can add blends. Now typically I will use blend mode nodes from Wassued because they have a lot more options than the standard image blend that comes with ComfyUI. So I'm going to be using that. I'm going to be using just the simplest one, which is add, which is basically the second image, the B one, is technically on top, and it sets the transparency of that top layer of the image basically. We're just setting the transparency of that and sending it out there. And if we cue the prompt, now this is going to make, it's not going to make a huge awesome image. It's going to make bad images because we need to do more to it to make it actually do really good stuff. But this is to show you the effects of having all this kind of gray and little dark and light patches on the denoising process. As you can see, it's got enough in here to already start making mountains like really early in the process of making the images. But this is because it's already starting at steps. We raise that to 1. We'll use more of the original. Okay, so it just made a random thing up here. And you can see that at 7, instead of being this black and white thing, it's actually able to make stuff because there's gray. And gray lets it just kind of make whatever it wants to make. I might as well make a preview so you can actually see what it's actually doing over there. But as you can see, yeah, the more kind of grays and the more stuff that's in our original image, the more it will allow this to actually work even further down and further down. Whereas if this was this, it would be a very plain and very empty image. So cancel the job and rerun it, and now we get to see what we're actually making because forgot. Okay, so we've got more dark down the bottom. The only real thing about this, since we're adding transparency to that, we reduce this, we should get more dark down the bottom, and it will still be a little bit cloudy. So we'll go down to 19. Cancel, rerun. So as you can see, now it's kind of a cloudy gradient. We're giving it a lot to work with when we do this kind of thing. At this point, this stuff is not hugely helpful. So generally just ignore the outputs there. You can build your own testing rigs like this whenever you want to do stuff and experiment with stuff. I suggest building testing rigs. And testing rigs, you could use XY plot to do these kind of things, where you have a whole range of values, the CFG, the denoise, all that kind of stuff. I don't generally use XY because my needs are a bit simpler than an XY plot, and I like to kind of work on one value at a time rather than a whole bunch of values, so I don't really need the complexity of an XY plot. So as you can see, we're getting black and white images because we're sending it black and white information. The further down we go, still black and white. And still kind of roughly as simple. There's a little bit of mountains and stuff like that in certain areas. And that all comes from because we've got a little bit of stuff to work with at that point. Now, if we go over to here, let's set this at, we'll end it at 20, so we're ending it, we'll end it at 15, and then we'll start it at 10. So we're going to get 5 frames. Like, I can't do maths, I'm terrible at maths. So I don't know what the denoise would be, but it'll give you an idea of what it's doing when we run it. So if we run this again, runs here, and then keep going. So that's kind of the stuff that it will generate when it's got a fair bit of the original image is showing up. Now, unlike an image-to-image process where you load an image with obvious features and stuff like that, because this is kind of a noisy, weirdly cloudy thing, it'll just make stuff out of it. And like when you look up at the cloud in the sky, it'll just make its own things. A lot further down than you might expect. So this is at 50%, and it's still making obvious features out of it rather than using the original image at all. So if you provide stuff this, you can go really far down the denoise and still get images that don't look like the original clouds as well. So, all right, color. Let's have a look at what happens when we add color to this, shall we? Let's change the gradient to, where's red? Red up top, and we'll change the bottom to turquoise. Why not? If we run this, click cancel, still haven't gotten to that one. So now we're giving it something completely different than what it would be expecting. Bright red sky, bright blue down the bottom. Now obviously the other one at this kind of denoising level, it was able to make features, but these are very bright colors. Now if we look over at denoise 1, we'll see that they're actually affecting the image that we're putting up the top. That's because of, as I said before, the intensity of the image. So black and white will really affect denoise of 1. So will really bright colors, like at maximum values, like close to 255. It'll actually change the thing at denoise, but if it's too far down the color kind of value, it'll just kind of bomb out and ignore them in the denoise of 1. But as you can see, there's so much of that color in there and so much of that value that it doesn't know what to do with it, even though there is this kind of cloudiness in there. It doesn't have enough to change the image significantly. Yeah, as you can see, things don't necessarily work as you expect. It's not like the kind of you would kind of expect that color would work roughly at the same kind of way that black and white would, but it doesn't really. And I can kind of show you that a little bit if we grab. Do I have one? Grayscale. Can I make something gray? All right, found it. Swap color mode. Luminance. Luminance allows us to remove the color information but keep the intensity information. So this is basically what it would be sending, that the stuff in here that is kind of the high value stuff, the lighter colors here are being used more than darker values here, basically, is what it's doing. So if we change this to something a little bit more muddy, light dark gray, and then light gray, I guess. Maroon, I guess we'll do it. Okay, yep. Experimenting. Okay. Ooh. Experimenting as we go. So as you can see, it is using kind of some of the red, but it's not using the exact shade that we have here. It's using kind of light and dark as well. It's treating the upper section more as darker than it's treating it as the actual color. So up the top, it's actually going black. And this is a result of both the prompting and the whole everything else. But it's still kind of give you an idea of what it's actually looking at here, and what it's actually using is not exactly what you would think it's using, because its system of what it decides is more important is a little bit different than once it starts using less than full denoise, because full denoise it's really just using this and a little bit of color information behind it, whereas further down it's using more this than it's using this. If we go over here, now obviously you can experiment with this stuff to your heart's content to see how these things affect images. You can do all kinds of stuff with this. Anything which can add or change colors in here is awesome. We can use, there's one more note I'll show you before we go to add a generate noise. So generate noise is a Vectra node. It creates colorful static, basically RGB, black and white, and it'll make pixels, and it just looks like confetti static. So if we generate, you can see colorful static. You can change some of the settings, how much noise there is, and all that kind of stuff as well. Now, because everything we use in here, generally you're just blending a whole bunch of things together. Doesn't really matter how you arrange things. We make sure that this can go over here because we're just experimenting with things, and we'll grab this into here. And we want to use this RGB value. We don't want to use too much of it. We just want to use enough of it so we're giving it something, but not Alright, let's grab a preview as well. We'll actually see what we're doing to it. There's a bit of tuning in involved when you're setting these things up, so. Alright. So we zoom right in, you can see there is actually RGB values in here, but they're being overwhelmed by the background. And the reason I add this kind of stuff is it gives the sampler the ability to change individual pixels to be kind of significantly different than ones next to it in the process. It's not like depending on the denoise value, obviously. Okay, so what the RGB noise really does, kind of re-explaining this because I messed it up a little bit, but the RGB noise, because it brings in this kind of these options for us to change colors, so it brings in RGB values, and because they're like, there's a lot of kind of difference between them. There's high contrast. What it does is when the blurring happens, the blur kind of becomes like smudged, kind of dotty kind of what's the best way of showing it? Actually, I might as well, if we run a blur, I'll just show you. Let's show you what it's trying to do. Let's run this at 16, why not, and give me a preview, thank you. I'm gonna ask you for, you hold down the Alt key and just drag stuff off and it'll copy a new one. So in theory this will render it at some point. Alright, here we go. So if you look over, you can see that it's actually still got that RGB color, but it's not individual pixels anymore. Instead, it's more like fist-sized lumps of color. So when we actually, this gets pushed to the sampler, what it's getting is these big kind of lumps of color instead of the small pixels. But because they're so kind of generic and kind of all over the place, what it does is when you have these big sections of color, as per when you have a gradient, what it does is it gives kind of this a little bit of a tint in a certain color when you mix it in certain ways, and that will allow the samplers to grab onto those little minor changes in RGB values and start adding different kind of details that would normally not really work if it was just straight up gradient. Which essentially has the effect of adding detail to an image. Now, the lower your denoise is when you add this kind of noise, the more, the sharper those details will be. So at a certain point, if you're so far down in the denoise, this kind of staticky stuff becomes film grain. So it can be also a way of adding film grain to your image if you add this in with a kind of low level denoise and maybe blend this in kind of using additive in low levels onto an image. You can really you can add a full-on film grain effect if you're after you know, almost realistic kind of video kind of stuff. I do that a lot, so like it's one of the things I love doing for horror images, making them look like kind of grainy photo and film, and you can really make stuff look realistic that would otherwise not really look realistic. Adds this kind of unreality to it that's pretty cool. So anyway, that's what it will do when you actually run this through the sampler. Okay, so I wanted to show you how to use this gradient module in some different ways, and unfortunately I missed it in the middle of that, so let's get started. So in order to actually use the gradient module in more than just the pre kind of effect area where you're working with samplers, you can actually use it as an after effect as well. So in order to say color grade or add a certain kind of effect, you can use this to add film effect. You can add just, you know, all kinds of stuff. You can use because basically it's just you're blending stuff using colors and you know, source images into each other in here, and because of that, all you really need to do is bring in you know, a source image which does not come from within here. Instead, it comes from another node or something like that. It's pretty easy to do. All you really do is you add a reroute. And what we do is we use a load. Load an image. I think I've got one in the thing. You can just paste it in. If you're in the workflow and you have a load image node, you can copy from other preview nodes and stuff like that, and you can put it into a load image node if you use this copy paste clip space thing, just for those who don't know. Now, if we plug this in here, we're now inputting the image into the front of the module. If you do this, make sure that your module is set up so that your width and your height is consistent through the entirety of the module rather than just at the end of it. Otherwise you will have stuff coming out odd resolutions and stuff not blending well. So just make sure everything in here is the same resolution if you're bringing something into it, because stuff in here, it's quicker if you're running it at 512 resolution, which is what I showed earlier, which is this module running at 512. It'll render stuff a lot faster. But if you're using this as a post process, you're going to have to do it at the same resolution as anything coming into it. Not doing that, you get, it's just not great, but it is slower, so be aware of that. If you just want to use this to modify an image, you don't have to put it out as a latent output, really just outputting it after here. So if we run this through here and we run let's run a blending. This is just to quickly show you rather than to make anything spectacular. And run through here and we'll use color. So we're just going to change the color of the image using this setup. So we'll shift it to about 60% towards the blue and the other color. Let's put these side by side underneath it and we'll run it. Hopefully it doesn't try to do everything else before it does this section of the workflow. I'm hoping it should just run these nodes. There we go. Now that's a quick way of just completely changing the color of your image if you didn't like it and just making it different. Just using color blending. Really powerful little node, this image blending mode node. So anyway, thank you for watching. More tutorials coming out. Eventually, I'm very, very busy. So unfortunately, I don't really have the time to devote right now to making a ton of tutorials. Unfortunately, I would like to, but yeah. Anyway, hopefully this helps. I'm trying my best to help you out in as much as I can. So thank you for watching.